Good day everyone, it's me again, Teacher Marlene. Now, I am going to discuss about the graphs of quadratic function. On this video, we will show different forms of graph satisfying y is equal to ax squared plus bx plus c. Then we are going to determine the effects of a, h, and k in the graph. And from there, we will state the properties of the graph of the quadratic function. Before anything else, let us describe some important terms. Let us start with the domain. It pertains to the value of x. We are the one choosing the value of x from the set of all real numbers. Now, the partner of the domain is called range. It is the value of y. We call this as dependent variable because its value depends on our chosen value of x. In a function, we can determine range as the set of y such that y is greater than or equal to the value of k. Now, what is the vertex? It is the value of hk in a vertex form of our quadratic function. We can describe it as the minimum or maximum point. If we have the minimum point, the parabola opens upward. In contrast, if it obtained the maximum point, the parabola opens downward. Next is the axis of the symmetry, defined as the line that divides the parabola into two parts, such that one half of the graph is the reflection of the other half. This line pertains to the x in the value of h. Another term is the Xintercept. It is the point that touches the x-axis or the horizontal line of our Cartesian plane. Its coordinate is x0, meaning the value of y is 0. On the other hand, we have the y-intercept. It is the point that touches the y-axis. Its coordinate is 0y, meaning the value of x is 0. Now, let's describe the graph of y is equal to ax squared. In our graph, the one that opens upward is y is equal to x squared, where the value of a is equal to 1. The inverted graph is y is equal to negative x squared, where a is equal to negative 1. Let us have another graph. The one that opens upward is 5x squared. Its a value is 5. While the graph that opens downward is negative 5x squared, where the value of a is negative 5. Can you now determine the role of a in the parabola? Take note that if the value of a is positive, the graph opens upward. And if the value of a is negative, the graph opens downward. Now let us discover the properties of the graph of y is equal to ax squared. Look at the following graphs. We have 5x squared. Innermost is y is equal to 10x squared. The outermost is y is equal to 1/5 x squared. Then beside it is y is equal to 1/2 x squared. If we arrange the values of a from smallest to largest, observe that we will have 1/5, 1/2, 5, and 10. So take note If the value of a is getting larger, the graph becomes narrower. On other hand, if the value of a getting smaller, the graph becomes wider. Now let's take a look at the graph of y is equal to x squared plus k. So here, the value of h is equal to 0. These are the graphs. We have y is equal to x squared. We also have y is equal to x squared plus 4. Then y is equal to x squared plus 6. Then y is equal to x squared minus 4. And y is equal to x squared minus 6. Observe that we are having vertical shifting. If k is equal to 0, observe that the vertex is on the origin. If the k value is greater than 0 or positive, shift the vertex of the graph k units upward. While if k is less than 0 or negative, shift the vertex of the graph k units downward. Now let us see the graph of y is equal to the square of the quantity x minus h, where k is 0. Now look at the graphs. The vertex is in the origin, so the function y is equal to x squared. Observe that the vertex moves 2 units to the right, so the function is y is equal to the square of the quantity x minus 2. If from the origin, the vertex moves 4 units to the right, the function can be y is equal to the square of the quantity x minus 4. On the other side of the origin, the graph moves 2 units to the left, so the function is y is equal to the square of the quantity x plus 2. And when the graph moves 4 units to the left, the function is y is equal to the square of the quantity x plus 4. Observe that the horizontal shifting is happened. So, if the value of h is greater than 0 or positive, shift the vertex of the graph h units to the right. And if h is negative or less than 0, shift the vertex of the graph h units to the left. Let us combine this together in the function y is equal to the square of the quantity x minus h plus k. Looking at the graph, the dotted parabola is on the origin as its vertex. The function is y is equal to x squared. Since the vertex moves 2 units to the right from the origin, so h will be equal to 2. Then continue moving 1 unit upward, so k is equal to 1. But observe that the graph opens downward, so the value of a is negative 1. Therefore, the equation is y is equal to negative of the square of the quantity x minus 2 plus 1. In general, slide the graph of y is equal to ax squared horizontally h units and then vertically k units. Now let us draw the graph of y is equal to the square of the quantity x minus 3 plus 2. This is the vertex form Let us transform this into general form by getting the square of the quantity x minus 3, which is x squared minus 6x plus 9. Then combining similar term, the function is now y is equal to x squared minus 6x plus 11. Let us make a table of values. If x is equal to 0, by substitution, 0 squared minus 6 times 0 plus 11 will give us 11. If x is equal to 1, we will have 1 squared minus 6 times 1 plus 11 simplified to positive 6. Now what is y if x is equal to 2? So 2 squared minus 6 times 2 plus 11. This gives us positive 3. Then if x is equal to 3, what is y? So 3 squared minus 6 times 3 plus 11, our answer is positive 2. Then, if the value of x is 4, we will have 4 squared minus 6 times 4 plus 11. Thus, the result is positive 3. Plotting these points in the Cartesian plane, the graph will look like this. Observe the coordinates 0, 11, 1, 6, 2, 3, 3, 2, and 4, 3. This made the parabola. Now let us complete the table below using the function that we have drawn. By looking at the graph, let us find the domain. As is stated, the domain is always the set of all real numbers. How about the range? So in our previous discussion, y is the set of numbers such that y is greater than or equal to k. Therefore, y is a set of numbers such that y is greater than or equal to 2. Now, what is the opening of the graph? Now, since the value of a is positive 1, it opens upward. So, what is now the value of the vertex? Looking at the value of h and k in the vertex form, we have 3, 2. How about the axis of symmetry? Looking at the value of h, then x is equal to 3. What is the x-intercept? Looking at the graph, it doesn't touch the x-axis. Therefore, there is no x-intercept. And which point touches the y-axis? The x-intercept is 11. Let us look at another example. So y is equal to negative 4x squared. If we put it in a vertex form, y is equal to 4 times the square of the quantity x minus 0 plus 0. Now let us complete the table. If the value of x is negative 2, so y is equal to negative 4 times negative 2 squared, we will have negative 16. Then what if x is equal to negative 1? So y is equal to negative 4 times the square of negative 1. That gives us negative 4. While if x is equal to 0, the value is also 0. If x is equal to 1, so negative 4 times the square of 1 will give us negative 4. And if x is equal to 2, negative 4 times the square of 2 will give us negative 16. Let us plot the points negative 2, negative 16, negative 1, negative 4, 0, 0, 1, -4, and 2, -16 in a Cartesian plane, this will result in a graph that is inverted since the value of a is -4. Let us complete the table. The domain is the set of real numbers. So the range is pertaining to k value. So k is the set of numbers where y is greater than or equal to 0. How about the opening of the parabola? Since the value of a is -4, it opens downward. Our vertex is at 0, 0. The axis of symmetry is x equals 0. So by looking at the graph, what is the point that touches the x-axis? So our x-intercept is x equals 0. At the same time, if x equals 0, the y value or the y-intercept is 0. Well, I know we have so much learning for today, but take all difficulties as a source of strength, because difficult roads often lead to a beautiful destination. God bless everyone!